Now, polynomials we're going to be looking at. Students will investigate characteristics of polynomials. You'll be using some properties from algebra to simplify and use some operations on those polynomials. All right, so here we go. Since we are going to be working with polynomials, it's nice to know what is a polynomial. So here we go. You know mono means, what does that mono mean? Like one. Anybody know what poly means? Many or more than one. All right, so what we're going to be looking at is a polynomial. And polynomial is defined as a monomial or the sum of monomials. So we're going to have more than one monomial today. We may have two of them. We may have three of them. We may have four of them. And depending on how many terms we have, we classify those with certain names. And I'll tell you what those names are here in a minute. So again, polynomial is a monomial or the sum of monomials. Now, as we saw yesterday, if we have one term, like we do right here, we call this a monomial. That's the type of problem we were looking at yesterday. Those are the type of terms we saw yesterday, monomials. Of course, mono means one. But if you look at this next example has two terms. So what are we going to call it if there are two terms? We're going to call it a binomial. Bi meaning two. Just like a bicycle has two wheels, a binomial has two terms. So bi means two. The next example we come across here, this one has three terms. What are we going to use for three terms? Trinomials. Tri meaning three. Just like a tricycle has three wheels, just like a triangle has three sides, a trinomial has three terms. All right, so over here we should have three terms. So mono means one, bi means two, tri means three. The next example we have has four terms. What do you call it when there's four terms? That's right, polynomial. Once we get to four or more terms, we're just going to be generic and call it a polynomial. We're going to be real specific with one term, two terms, and three terms. But after that, we'll just be generic and say polynomials. Okay, so four or more terms, we're just going to call it a polynomial. All right, so polynomial just means more than one term. Now we're going to be looking at how to work with those. But before we do that, degree of a polynomial. We know that degree of a monomial is the sum of the exponents. So what's the degree of a polynomial? It says here the degree of a polynomial is going to be equal to the highest degree of the monomial terms. The degree of a polynomial is going to be equal to the highest degree of the monomial terms. So we'll look at a couple of examples. So in this first example, they give me a monomial. This right here is a monomial. And the degree of that monomial is 5. How did we get that 5 again? We added up the exponents. 2 plus 3 gave us a 5. And since we only have a monomial or one term, the degree of that would be 5. Going to be exactly the same thing. If we look at the next one, though, what kind of polynomial do we have here? Bi. It's a binomial. We got two terms. So what we're going to have to do on this one is identify what the degree of each term is. So this is what I mean. This first term, what's the degree of that first term? 2. What's the degree of this second term here? 1. So what I want you to do is I want you to write down those two numbers for me. 2 is the degree of the first term. 1 is the degree of the second term. Now, according to our definition over here, it says the degree of a polynomial is equal to the highest degree. So out of these two numbers, which one is the highest? 2. Therefore, the degree of this polynomial is 2. We're going to be looking for the highest degree of each of those terms. Let's look at the next example. This next example has 3 terms. When we have three terms, we call that a trinomial. So what's the degree of this first term right here? 2. The degree of the second term would be a 1. And let's see if you remember, the degree of this one is a 0. All right, so we should be writing three numbers down here, 2, 1, and 0. These are the degrees of each of the terms. What I want is the highest of those three numbers. And the highest of those three numbers is the 2. So the degree of this polynomial is 2. We're always looking for the highest. All right, last one. This is a polynomial. I want to know what's the degree of each of the terms. So let me start right here. Anybody know what the degree of that term is? 5. That's right. Remember, we're adding up the exponents. So 4 plus 1 is 5. What's the degree of this term? 3. The degree of this term is 2. And the degree of that last term is 0. So the numbers we should have written down are 5, 3, 2, and 0. I only want the highest degree, the highest number. And the highest number is the 5. So the degree of this polynomial is going to be 5. It's the highest degree of that term, that first term. All right, so that's what the degree of a polynomial is. It's the highest degree of the monomial terms. Now we're going to start working with some operations with those polynomials. It says to simplify polynomials with addition, subtraction, and multiplication, what we're going to have to do is clear grouping symbols using some properties of algebra like distributive property. We're also going to have to combine some like terms using properties from algebra like the commutative and the associative properties. Now don't worry about too much about the definitions themselves, but we should be able to use distributive property. I think everybody's familiar with that. All right, so here we go. Let's start looking at some examples. Number 1, notice on this over here, we have a 2 on the outside of the parentheses. So we're going to have to use some distributive property here. So what I'm going to do is I'm going to distribute that 2, and I'm going to multiply it with the 3x squared. And 2 times 3x squared is 6x squared. I'm going to take that same 2 and multiply it with my negative 3xy. What do you get when you multiply with the negative 3xy? Negative 6xy. We're going to do that one more time. 2 times negative 5y squared would be a negative 10y squared. All right, so this is what I get after distributive property. What I'm going to do is I'm going to take this and I'm going to add it with this other polynomial. I'm going to add it with the negative 4x squared minus 3xy plus 5y squared. I'm going to add those two together. Now remember, when you're adding, you can only add things that are alike. And I mean they got to be exactly alike. So I can add x's with other x's. I can add x squares with other x squares, and so on and so on. So I'm going to start right here. I'm going to take this negative 4x squared, and I'm going to add it with this 6x squared. They are like terms because they both have x squares. What do you get when you add those two together? 2x squared. Remember, we don't touch the exponents when we're adding and subtracting. It's only when we're multiplying and dividing that we mess with the exponents. Now I'm going to take this negative 3xy, and I'm going to add it with this negative 6xy. Those are like terms because they both have xy. What do you get when you add those two together? Negative 9xy. And now what I have left is this 5y squared. We're going to add it together with that negative 10y squared. What do you get when you add those two together? Negative 5y squared. Can I do anything else? No, that's it. There are no more like terms, so I'm going to stop right here. Stop right there. By the way, that answer we just got, would that be considered a monomial, binomial, trinomial, or polynomial? Trinomial. I want you to write that down for me. Trinomial. Anybody know what the degree of that trinomial would be? 2. The degree would be 2. It's the highest degree of the monomial terms. All right, so there's our first one. Number 2, very similar. We're going to subtract this time, though. So let's come over and subtract. We're looking for like terms. I'm going to take this 3x squared, and I'm going to subtract that negative x squared. What do you get when you subtract those two? It's 3x squared minus a negative 1. 4x squared. 4x. Now let's take that 6xy and subtract 5xy. What do you get when you subtract those? xy. 1xy. Now, we could put the 1, but it's not necessary. So xy is what we get. Now let me take the y squares. Negative 7y squared minus a negative 2y squared. What's a negative 7 minus a negative 2? Minus 5y squared. And since there are no other like terms, we're done with that. We can stop. That is our answer. By the way, what is that called? Monomial, binomial, or trinomial? This is a trinomial. And what degree would that trinomial be? 2. The degree of that trinomial is 2. Okay, we're moving on to number 3. Now on number 3, we're going to have to use some distributive property. We're going to get rid of those parentheses. So what we're going to do is we're going to come over here and we're going to distribute this 3xy squared. We're going to multiply it with the 5x squared y. Now remember, we're multiplying here, so we are going to touch the exponents. But we're going to start by multiplying the big numbers. Somebody remind me what we call those big numbers like the 3 and the 5. Coefficients. So 3 times 5 is a 15. X times an x squared is an x cubed. Remember, we're adding exponents. Y squared times y would be a y cubed. Again, we're adding the exponents. Okay, now what I'm going to do is I'm going to take that negative 3xy, and this time I'm going to multiply it with the negative 6xy cubed. So 3 times a negative 6 would be a negative 18. What do you get when you multiply x times x? X squared. Y squared times y cubed is y to the 5th power. Can I combine those two terms? No. That is my answer. That's the answer. By the way, what would that be called? A monomial, binomial, or trinomial? That is a binomial. What degree would that binomial be? What's the degree of the first term? 3 plus 3 is 6. What's the degree of the second term? 2 plus 5 is 7. What's bigger, the 6 or the 7? 7. Okay, so the degree of this polynomial is 7. Okay, number 4. Number 4, what we're going to do is we're going to multiply 2 binomials together. I know you've seen this back in Algebra 1. You've also seen it in your geometry class. How do you multiply 2 binomials? We even had a little special name for it. Anybody remember this thing I had? Y'all familiar with that? No? No? FOIL method. That's just a fancy name for distributive property. All we're doing is taking this x and we're going to distribute with those 2 terms in that other binomial. So we're going to multiply x times x, which is going to give us x squared. What we just did was we multiplied the 2 first terms. That's what that S stands for. Then what we're going to do is we're going to multiply that same x times that negative 3. X times negative 3 is negative 3x. What we just did is multiply the outside terms. That's what that O is for. Now what we're going to do is distribute the 8. Distributive property. We're going to do 8 times x. 8 times x is going to be a 8x. We just multiplied the inside terms. That's what that I is for. And finally, we can multiply 8 times negative 3. 8 times negative 3 is a negative 24. L stands for lax. Now, do I care that you remember FOIL, the name? No. All I care about is you being able to use this distributive property twice. Is that the answer, though? No? Why not? You have like terms, so we need to combine those like terms. These are the like terms. Combine them. What do you get when you combine those terms? 5x. When you combine those, you get 5x. Of course, you still got your minus 24, and you still got your x squared. So this right here is what we're looking for. What is that thing called? Trinomial. And what would be the degree of that trinomial? 2. It's the highest degree of the monomial terms. Number 5. Number 5, we've got x plus 4, and they want us to square that. Now, before I do that, though, if I were to ask you guys, what is 5 squared? Anybody know what 5 squared is? 25. How do you know it's 25? Because 5 times 5 is 25. So when they ask you to square something, they're asking you to multiply that thing by itself. So that's what I need to do here. I need to take this x plus 4, and what I need to do is multiply it by itself. So all we're doing is some more important distributive property. So it's exactly like number 4 that we just got through doing. I'm going to take x, and I'm going to multiply it with this x. So x times x is going to give us an x squared. Take that same x, multiply it with 4. X times 4 is 4x. Now I'm going to do distributive property with the 4. So 4 times x is going to give me a 4x. And 4 times 4 is 16. But is that the way we're going to leave the answer? Or can I do anything else? Yeah, combine those like terms again, which are these two right here. Those are the like terms. So what do you get when you take 4x and you add another 4x? You get 8x. Of course, you still got your 16 over there. So this is our final answer. All right, so what is it? Binomial, trinomial, or monomial? Trinomial. What's the degree of that trinomial? 2. Trinomial. Number 6 is just another multiplication of 2 binomials. So same exact thing we just got through doing. Let's take the 2x times the 2x, which is going to give us a 4x squared. 2x times a negative 3. 2x times a negative 3 would be a negative 6x. Now we're going to do distributive property with the 3. So when I multiply 3 times the 2x, that's going to give me a 6x. And finally, 3 times a negative 3. 3 times a negative 3 is a negative 9. Marissa, is that how my answer is going to say? No. What are we going to do? Combine the like terms. Now what's going to happen when we combine those 2 like terms? They go away. They cancel out, right? Because a negative 6x plus 6x is 0x. So there are no more x. So all we have left is 4x squared minus 9. So this is the answer we're looking for. What are we going to call that thing? Binomial. And what degree is that binomial? 2. All right, now let's take a look at some application. These are the type of questions you may come across on your next test here. Number 7 says that we have a rectangle that has a width represented by 4x plus 5 and a length that's represented by 3x plus 2. What we're trying to do is we're trying to find the area of that rectangle. So the question is, how do you find the area of a rectangle? Length times width. So let's write down the formula. Area is equal to length times width. And we know both of those things. We know the length. It is 3x plus 2. We also know the width. It's 4x plus 5. So what we're going to do is we're going to find the area by multiplying those two together. So it's just more of the same thing. It's multiplying the 2 binomials. Distributive property twice. So 3x times 4x is going to give us a 12x squared. 3x times 5 is going to give us a 15x. Now I'm going to do distributive property with the 2. 2 times 4x is 8x. And 2 times 5 is a 10. But we're going to clean that up. We're not going to leave it like that. We have some like terms. These two in the middle right here are like terms. So if we were to put those together, what are we going to get when you put them together? What was it? 23x. And of course, we still got the 10. So the area would be represented by this expression, 12x squared plus 23x plus 10. And we got that by multiplying the length times the width. So there's number 7. One more. Number 8. Number 8 says that the diagram below shows an isosceles triangle. Anybody remember from geometry what an isosceles triangle was? 2 sides are equal. Can you tell me which 2 sides are equal? Yeah, the ones that have the little lines on them. These little lines right here are telling us that these 2 sides are equal to each other. So 3a plus 5 is this side, and this side is also going to be 3a plus 5. All right, so now that we've got that taken care of, it says find the expression that represents the perimeter of the triangle. How do you find the perimeter of a triangle? Add all the sides. So what we're going to do is we're going to take all the sides and add them together. So I'm going to take 3a plus 5. That's one of the sides. I'm going to add it with 3a plus 5. That's another side. And we're going to add it with a third side, which is 3a squared plus 2a minus 1. We're going to add all 3 of those together. All right, so here we go. We're going to start by adding all the a's. So I've got a here, and an a here. So if I add 3a plus 2a, what do you get when you add all that together? 8a. 8a. Now I'm going to take these numbers right here that don't have any letters on them. Anybody know what you call numbers that don't have letters on them? Constants. We're going to add up the constants. So 5 plus 5 is 10. And 10 plus a negative 1 would be a 9. Odd to 9. Now notice we have an a squared here. Can I add that with anything? No. So we're just going to bring it on down as our 3a squared. So this is what we get when we add all the like terms. This right here would be the expression that represents the perimeter of this particular triangle. Now keep in mind, guys, it doesn't necessarily have to be in this order. If I wanted to rearrange the terms and write it as 3a squared plus 8a plus 9, there's nothing wrong with doing that as long as I've got all my terms with the correct signs on. All right, so that takes us through working with polynomials. Like I said, you have covered this back in Algebra 1, so this was just a review of some things you already knew.